to give two indexes. So if we did go to number grid at index 2, 3, we'd go to row 2, column 3, and we would be here with this number 42. So that's how we could set a value inside this two-dimensional array. Does that make sense? Are there any questions about that? Okay, so yeah, row 2, column 3, we can put the integer data in there. Okay, I can also initialize my two-dimensional array as well, like we did with the one-dimensional arrays with these curly brackets, this static initializer. And I've laid it out so it looks like what we can imagine it to look like with its rows and columns. C doesn't care if you just put them in a long list along on the one line. I like it like this. Yeah, so we've defined 3 rows with 5 columns each, or 5 pieces of data in each array. Yeah, and this is what it would look like. So if I went to row, if I went to if I went to the index 1, 0, what value would I get? Yes, so this would be row 1, column 0. That's right. Cool. If I went to row 3, column 2, what would I get? Error. Yeah, who said error? Yes, good. There's no row 3. Okay. The last row is row 2. Okay. If I wanted this thing here, what would the index be? Yep, row 2, column 4. So hopefully you've got the idea of that. Now, again, like we don't want to have to go through and hard code all this stuff, like all the different indexes if we want to look at all of the items in the array. We want to be able to do this thing with loops. And because we've got sort of a two-dimensional array, we want to have something like a two-dimensional kind of loop. So we're going to have a nested loop to do this, with one of the loops controlling the row indexes and the other loop controlling the column indexes. And we've actually done loops that are almost exactly right before. When we do something like this, we end up with something like, well, we start with row is equal to 0, and then we have column is equal to 1. Oh, no, we don't. Gosh. Column is equal to 0 as well. I'll just get rid of this actually. So we've got row is equal to 0, col is equal to 0. That's how it starts. And while the row is still equal to 0, col gets incremented. Okay, and we have, actually let me draw it like this. We have our row 0, and we end up with col 0, and that gets printed. We increment col, we get col 1, it gets printed. We increment, it gets printed, etc. When we get to the end of our, the size of the columns, we print a new line and we increment our row. So now our row would be 1. Then we go through column 0, 1, 2, 3. We increment our row again and we go through this again. So we did something like this that just prints numbers out on the screen. If we actually change this and like access our array at index row col, then we're doing an array, two-dimensional array traversal. And I'll go through this in much more detail. So we've adapted that kind of nested loop we've seen before, but now we're using these row and col counters as the indexes in our 2D array. So we're going to print out the array at index row, index col. And we've got these nested loops. And up here, I've declared all the data in the array, and I've got the picture that resembles my, to represent that array over here. So when we start, we call this loop the outer loop, like the outside loop, the outer loop, and this one we call the inner loop. So the outer loop, the row is set to 0 and the column is set to 0. So we'd be printing out this first element here. then we're inside this inner loop. This inner loop's going around. So we end up setting col to 1, but the row is still 0. So now we're printing out this element. We're still inside this inner loop. So we increment col, we print out the next column. So we'd get this one here. And that would be printing out row 0, col 2. We're still in this inner loop. We increment col, and we're printing row 0, col 3. Now at this point, we increment col. Col is equal to 4, and our loop stops, and we print a new line. If we keep going now, we're incrementing our row counter. So our row gets set to 1, but our col gets set back to 0. So now we're at row 1, column 0. We keep incrementing col. We keep printing out these elements row by row. We get to the end of the row. Col becomes 4. The loop stops. We print a new line and we increment row again. And then we start, set col back to 0, and we start again on this last row. When we get to here, our row would be incremented to 3, and the whole outer loop would stop, and we would have printed everything out. So this kind of loop allows us to go through all of the cells, starting at row 1, going across the column, moving to the next row, going across the columns, moving to the next row, going across the columns. Like that. Are there any questions about this? Do you want me to go over that again, or does that kind of make sense? Any questions? All right, so that's not it. We're going to do some coding examples. So let's go and do some coding examples with 2D arrays. Okay, where am I? All right. All right, so what do I have here? I've got this quite small two-dimensional array. We've got 2 rows and 3 columns. Okay, so is everybody happy with this little array? Now I could draw it again. I'll draw it here. I've got 3, 5, 1, 2, 4, 9. And for the indexes, I've got 0, 1, 0, 1, 2. Okay, so that's my array. What the program does at the moment, we're just playing around with stuff. So if I type in a row and a column, like 0, 0, it's just going to print out the element at 0, 0, which is going to be 3, right? Is everyone happy or following? I can type in 1, 0. What's that going to give me? Row 1, column 0 is going to give me the 2, whereas row 0, column 1 is going to give me the element 5. Yeah, good. If I do something like row 0, column 3, yeah, crash. Index 3 is out of bounds. Our columns only go up to 2. So this is just playing around with using the indexes and getting data out of it. Any questions about that? Okay. I'm not going to write the proper print grid yet, but imagine I did something like this. What I want to say, in this example, you might notice I haven't passed in these functions, I haven't passed in any of the sizes of the dimensions as arguments to my function. So in this case, I'm just assuming that we're just writing code that's only going to work for this particular size grid, and that we're going to use these hash defines to know what the size are. So it's not very flexible. It's just sort of a hard-coded, we can only have a 2x3 array that works in any of these functions, just to make it simple for the first time we're doing it. So when I'm calling the function, I just pass in the grid, and within the function, I just use these hash defines. Okay. Oh, why am I calling it I? Gee. Okay, and there's no comma here. There we go. Let's see your sort of C reading skills. Can anyone work out what this might be doing? Yeah, that's exactly right. This is just printing out all of row 0. Let's try it. Oh. I'll get rid of this initial code because we've played around with that now. There we go. Okay, I've compiled it again. Let's run it. Okay, so yeah, this code here, we've hard-coded the row 0. We're going to row 0 every time. We're starting at column 0, and we're printing out 3, 5, 1. So we've hard-coded the row. We're just going and printing out all of the columns. Now, obviously, this is great if we wanted to just print out the row, one row. If I wanted to print out row 1, I would change that and hard code it to 1. You know, that could print out all of row 1, going through all the columns. But instead of that, I want it to be more general. I want it to be able to print out any row, and I want it to start from row 0 and go through all the rows that I want. So this is why we put it inside the nested loop. So let me put the whole thing together. I was just trying to explain it in a slightly different way. I've got to remember to increment row. Okay, so now instead of say hard coding the row, the first time round row will be equal to 0, and it'll print out the first row. The second time row, the row will be equal to 1, and it prints out the second row. Okay, does that make sense? Do we want to explain it again or move on? Move on? Okay. All right. Now, if we want to read in this grid, it's very similar. In fact, I'm going to copy and paste the code. And it's very similar to what we could do with a one-dimensional one. Instead of doing a printf, we do a scanf. And when we read it in, we use the same indexing, we just change it to ampersand. And we don't need to print this out. But again, when we're dealing with two-dimensional arrays, a lot of the times if we're going through the whole array one by one, row by row, this is the kind of loop that we use. So I'll show you a few other things you can do with this kind of loop. And then we'll shake it up a bit. Let's scan in our grid just to see that we can do it. And then print it. So instead of hard coding at this time, I'm scanning it in, which again is annoying. I've got to type in stuff. I'm going to type in the same stuff. Yay. So I can scan in data as well. Okay, let's do something else. What we're going to do is we're going to sum up every value in the grid. So how are we going to do that? So I'm going to get rid of the scanning. I don't want to keep typing it in. Let's have our hard-coded two-dimensional array. And I want to get a sum. Okay, so I'm just going to pass in the grid, and some grid wants to add up all the data in it. So we want 3 plus 5 plus 1 plus 2 plus 4 plus 9. That's what we're trying to do. So the first thing I'm going to do is what? What am I going to do? I'm trying to find the sum of this two-dimensional array. So the first thing I'm going to do is I'm going to have like a sum variable that I set to 0, and every time I look at one of the elements in the array, I'm going to add it to my sum. Okay? But how do I look at every element in this array? Yeah, I basically do a while loop, just kind of like what we've already done before. So I do int row, and I go through every row in this grid. And for every row, I go through every column. But I've got to make sure actually I initialize my column each time. So this kind of shell of a loop, this 2D loop I've got, I can kind of use this for anything with a 2D array usually, not everything, but a lot of things. It's just a matter of what I'm doing in here, what I'm doing with every element in the loop. Sorry, I'm going to hear something weird. So in this case, I am visiting every element at the given index row col, and I'm adding it onto my sum. So instead of printing it out, I'm adding it onto the sum. And at the end, I'm returning the sum. All right. Is everyone happy with this? Is this going to work? Okay, I get 24. Now the golden rule of testing your program is to know what the answer is supposed to be. Is the answer 24 right? Good. Now what's going to happen if I do this instead? So I've moved this col equals 0 to here. What's going to happen? What do we think? because this is actually a common mistake. Let's try it. The sum is 9. So what's happening here, and this is a common mistake, we start off with, sorry, was somebody answering something? Yeah, this inner while loop is only going to run once. So we start off with row 0, and col is equal to 0, and we end up summing the 3. We move col on to 1, we sum up the 5, we move col on to 2, we sum up the 1, we move col on to 3, and that loop stops. And col is stuck at 3. It never gets reset back to 0. So now when we increment row will be 1, and we'll come in to do this, and it'll say, well, no, 3 is not less than 2, or 3 is not less than 3, sorry. And this loop won't run again. It'll only ever get to run once because we need to set it back to 0 so it has a chance to run again. Okay, so this is a very important thing to do. If you notice you've got something like this and it's only ever working for the first row, maybe you forgot to put this inside the loop and reset back to the beginning row every time. Okay, let's fix it. Okay, there we go. Well, let's put it back. There we go. Now it should be able to go through all the rows and get the sum of the whole thing. Okay, any questions? All right. Now the next thing we want to do is we're just going to go and print the sums of each row. We're not returning it because there's lots of different sums, but we want to basically go through the first row and work out that 3 plus 5 plus 1 gives me 9, and we want to print out the sum of row 1 is 9, right? Then we want to print out the sum of the next row is 15. You know, and if there were more rows, we'd want to print out their sums. So now we're not doing an overall sum for the whole 2D array, we're doing individual sums for each rows. So this is what you might need to do sometimes. Like you might be, imagine this was a game of connect 4 or noughts and crosses or something. You might want to go along different rows and check if people have all of the pieces in a row or whatever you're doing. So this is a common thing you might need to do. I keep deleting my beautiful drawing. Okay, so this would be, we've called it print row sums. Let's try it. And then we're going to do print col sums, which is going to, yeah, be a bit difficult once we're in this mindset. So we can do something like this actually. Now, if I just take this, this is going through a whole column. I mean, this is going through a whole row. So for every row, we do this in a loop, and it's adding stuff to the sum. And then we move on to the next row. So maybe I could just print out, okay, the sum of this row is whatever. So what row am I on? Well, I've got the row index. What's the sum? Here's my sum. Does this work? What's wrong with this? Yeah, I'm just adding up the sum. I'm just totaling the whole sum of the whole array as I go. So let's just run it though, but that's correct. So it says sum, oh, well, maybe I should put row in so it just is less confusing. So it's saying the sum of row 0 is 9. Great, this is working. The sum of row 1 is 24. Oh no, it's not working. But yeah, your suggestion was right. We need to start getting a new sum for every row. So now we need to set our sum to 0 back here. So our sum starts again at 0 for every single row. Oh. So let's try this. We've got a new sum starting at 0. We add on to it for the row. We print it. We reset it to 0 for the next row. Yeah, and that looks good. Okay. Does that make sense? All right. So we've done everything we've done so far. We've been doing row by row. We go to a row and we go along the columns. This time round, we're trying to find the column sums. Oops. So this is a little bit different. I'm wanting to get, well, the sum of column 0 is 5. The sum of column 1 is 9. And the sum of column 2 is 10, for example. I want to go through each column and find the sum. What do I do differently? How do I change it? Yep. Yeah, that's a great suggestion. I can swap the order of the loops. So now, instead of going row by row and having row as the outer loop, and for every row going through all the columns, which is the inner loop, I put the column as the outer loop, and for every column, I have the row as the inner loop. So for every column, I'm going through all the rows. Then I move to the next column, and I go through all the rows. So this is how I can do it for column by column. And for reasons, oh, shivers, what have I just done? It tends to be better to do most things row by row unless you've got a good reason. Like this, we've been told we want you to print the column sums. So now I'm going to change this. All the cols should be rows and all the rows should be cols. This should be row. Now we don't want to swap these indexes around, otherwise the code is exactly the same as it was before. The sum of each col, the sum of each col, and col plus plus. All right, let's compile it and try it. I didn't call my function. Do other people do this? Or is it just me forget to call your functions? Just me? Is this correct? The sum of column 0 is 5. The sum of column 1 is 9. The sum of column 2 is 10. All right? So sometimes you need to go column by column. This is how you can do it. What else do we have left? Let's see. Okay. All right, we've got time for this one last little thing. Now I'm moving to a different file because I want to do stuff on the diagonals, but it's going to be a bit awful if I don't have like a square grid. I'm not going to have a nice diagonal. So what I want to get the sums of the diagonals. Now, I don't know what you call these things maybe in maths, so I apologize. I'm calling this the top left diagonal because it starts at the top left. Okay, you might have a more technical name, which I've forgotten because it's been a while since I've done like my maths courses. So this is the top left. How am I going to find the sum of this? Sorry? Yeah, the pattern here is when, so this, I've drawn in beautifully the columns and rows. Sorry, I know my writing's messy, I'll try harder. This one here is row 0, column 0. This one here is row 1, column 1. this row, this one here is row 2, column 2, row 3, column 3. So this diagonal, we get that when the row index is equal to the col index. Does everyone agree? Yeah? 0, 0, 1, 1, 2, 2, 3, 3. How are we going to put this in our code so we're summing just those elements? There's more than one way to do it. How can I just make sure I'm summing things when, you know, it's row... Yeah, I can have just the same while loop I've done before. I think that's what you mean. Yeah? If it's equal to it. Okay, so I think what you're saying is we can do something like what we did before. I'll show you two ways. I'll open up my code. Again, I shouldn't have shut it. So I'm going to go and I'm just going to steal the code that we wrote already for here. And I'm going to change it because we don't have a different number of rows to columns. We've just got, you know, size. So this code's going to find just the sum of all of the elements in the whole 2D array. But we can just choose to add up the ones where row equals col. So if row equals col, we add it onto our sum. If row does not equal to col, we don't add it onto the sum. So if this works, we're going to get what answer? Everybody? 14. Good. Thank you. Let's compile this. Let's see if we do get 14. Yep, we got 14. And you might be thinking, how did we get 42 for top right? I just hard-coded a return value. Okay, there we go. Does that make sense? Is there any other way we could do it? Do we need a two-dimensional loop to do this? Yep. Yeah, I could increment row and column at the same time and have just not even have nested loops for this. So, in fact, I might not call it even row and col. I might just call it I, and I'll go, let's make I equal to 0 and go to the array at index II. Let's increment I to 1 and go to the array at index 1, 1. Let's increment I to 2. And that's how we can do this as well. Now, in this course, we wouldn't care which way you did it, as long as you did it a way that you understood and made sense to you. But it depends. Different things make different sense to other people. So let's try this. So I could do int. I could just call it index if I really wanted to. And because this is like a square array, this will work. And I can just say, oh, I've got to have a sum. What am I doing? Index, index. And then I return this at the end. All right. Ooh, we're nearly done. Let's just check if this works. Yeah, this works. This does the same thing, right? In this situation, we can do it. We're just basically going down the diagonal. Now, we don't have any more time today. In the next lecture, we'll do this other diagonal. The other diagonal is a little bit harder. Think about how we might do it. And thanks, I think we've got to go now. You can always leave feedback, otherwise I'll see you online. If you're owed chocolates, come and get chocolates. Oh, assignment 1 should be out. Go have a look at assignment 1. In 5 minutes,